All right, we're going to continue with our contrast of algebra and our transition of algebra to arithmetic. I said that backwards. We're going to continue our transition from arithmetic to algebra and transitioning from doing math that involves only arithmetic to doing algebra. We talked about the differences between the numbers that are used in algebra versus numbers in arithmetic. So what is the big addition between arithmetic then transitioning to algebra? What's the big addition in number groups? What? Negative numbers, right. So now we are going to transition from whole numbers, which are 0 in the counting numbers, to integers. And then we contrasted the operations and then the symbols. So I'm going to begin with the parenthesis, finishing up the section on symbols. Pretty much the most important symbol in beginning algebra, in basic algebra, in Algebra 1, therefore in pre-algebra, is the parenthesis. And the parenthesis has dual function. It's going to replace the times sign to indicate multiplication, but it is also the most commonly used grouping symbol. And with the parenthesis, we have a very important property, the distributive property. And so now in algebra, we are going to be using the parenthesis all the time. We're going to be using the parenthesis for multiplication, whether it's dealing with, this is a monomial expression times another monomial expression, or if we're going to use the distributive property, many times we'll have a monomial times a polynomial, more than one term. So the parenthesis becomes the most important symbol in basic algebra. We're going to be using it quite a bit. All right, and of course you know the distributive property, which states that when you multiply a factor times a sum, you must multiply that factor times each add-in or each term in the sum. Of course, there's going to be a lot of difference in terminology, which we'll talk about in just a minute. So parenthesis becomes the most important symbol, and it is used for both grouping and multiplication. If you can teach your students how to remove parentheses using the distributive property, and then teach them how to put parentheses back in, which is factoring, they'll be well on their way through most of basic algebra. So the parenthesis becomes the most important symbol in Algebra 1. So let's continue contrasting arithmetic versus algebra. We started the first lecture in this section showing, I put up an equation on the board and I put up a decimal division problem on the board, and I asked you which one you would rather do. So that brings us to the next contrast between the two, and that deals with computation. Especially with pre-algebra and especially with 7th and 8th grade and even into Algebra 1, the computation is simple versus tedious. In arithmetic, let me scoot this over, and we'll put arithmetic up here, and algebra right here, and we'll continue contrasting the two. And so computation here can become tedious. Think long division. Think long column addition. Multi-step computation. Okay. Dealing with decimal points and so forth. So the computation can be very tedious. We start doing multi-steps. Think about percent problems. where we have to deal with the decimal, we do a lot of division and so forth. So the computation in arithmetic can become quite hard, whereas the concepts are familiar and easy. And of course, they become easier and easier. They are less abstract. So in algebra, the computation, the actual numbers involved are often very easy. Okay, I showed you this equation. Here, to solve my equation, I have to inverse the 1 by subtracting it from both sides, and I inverse the times 3 by dividing it on both sides, and look at the computation. It's quite simple. 10 minus 1, 9 divided by 3. So we do have often the computation, the actual math, we might call it, is often easy, but the concept is more abstract. We are using variables. We are replacing numbers with letters. What's the alphabet doing in my math? Okay, how can a letter represent a number? And so the concepts are going to be new and a little more difficult at first because they're new and they are more abstract. So as we are dealing with computation, they can be tedious, but at least they're familiar, and the concept involved is not very difficult. Whereas even though the computation is easy, the concept can be, well, it is going to be brand new. Some of it may be a little hard to see at first because it's abstract. All right. And as long as we're talking about computation, we can now go to format. 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 Your format in arithmetic is vertical. If I'm doing addition, I will line up my add-ins vertically and do my computation vertically. In algebra, the computation tends to be written horizontally and often done mentally. So in my algebra, my numbers are easier. My format is different. I'm going to write things horizontally. I am going to combine my like terms. As you know, you've taken algebra. My problem's written horizontally. Much of the math is mental, and I am bringing down step by step. And I do have more concept here than I do here. Here I am doing the math, such as it is. If it was more long column, I would have to carry, and I do all of my work out in arithmetic, and typically it's in vertical format. In algebra, we write our problems horizontally and work the steps down, down, down. Often in arithmetic, we write our problem vertically. And where do our steps go? Out horizontally. See the difference in format? So here I'd get my common denominator, right? Then I'd do my borrowing. So I have 2 and 12/8. And then my answer is finally 1 and 5/8. See the differences in style. Vertical problem, horizontal steps. Horizontal problem, vertical steps. Okay? I work it down vertically, and the format is horizontal, and the format here is vertical. So it's a whole different idea. And if I were doing fractions in, if I was doing fractions in algebra, they're called rational expressions. I might have, let's say I have 3x over x plus 1 minus 2x over x plus 1. I would keep my common denominator and subtract my numerators. Let's see, I'm written horizontal, answer below. If I had to get a common denominator, it would be in horizontal format. Okay, so arithmetic and algebra are very distinct, and so we do have to make a nice transition for our students. Another difference is arithmetic involves whole numbers, fractions. I'm going to put decimals up here because they kind of are the next step with the, we're going to deal decimal math, whole number math, fraction math in algebra. We're going to use a lot more fraction formatting, okay? Because in algebra, we have a group of numbers that we call rational numbers based on the word ratio. So there's going to be differences there. So we've talked about now differences between the two, arithmetic versus algebra, and the fact that we must make a deliberate transition between the symbols, between the steps, between the operations, between even the format. And of course, the last thing I want to go through, which we are going to review some today, is order. The order of operations is only introduced here, and sometimes it's ignored. Sometimes we ignore the order of operations when we're doing drill and we're doing our mental math, don't we? We might say 10 divided by 5 plus 2 times 3, and so forth. But in algebra, the order is required and always followed. Algebraic order. Here we just call it the order of operations. Often we'll call it here algebraic order because we always follow it and we never violate it. What is algebraic order? What is algebraic order? It's the priority in which we do our operations. Okay, so algebraic order, the order that we must do our operations, first priority, what is done first in a multi-step problem. A lot of times students will tell me parentheses, and I always correct that. And I use this word instead. A lot of times it's a good idea to have single word answers to help the students remember. I use this word instead. The first priority is not parenthesis. Well, it is in some regards, but what is parentheses used for? We use it to group, we use it to multiply, so that's a little bit vague. And parentheses are not the only grouping symbol. So this, to me, is the key word. I have to start in the innermost parentheses, too. You learned that in high school when there's parentheses within brackets, within braces. We always start at the innermost parentheses. So it's a better idea to start with this word and get this word associated with the first priority. I do inside the grouping symbols first. Parentheses, that's true, but it's too vague, because parentheses can indicate multiplication, and there can be parentheses within parentheses, and brackets and braces, and there's other symbols involved. So inside grouping symbols must be done first. And that grouping could be this. What is that? What is the symbol? Absolute value. It could be underneath a radical. It could be simplify the numerator and denominator first of a fraction. So we're going to do inside grouping symbols first. Yes, most of the time they're parentheses. But I like using the word inside as my key word to think, what do I do first? I do inside. And if there's more than one grouping symbol, I work from the inside out, right? Then I will do exponents or radicals. Sometimes I just call those powers, because technically a radical is a fractional exponent. Do you remember doing rational exponents? Square root of x is x to the 1/2 power. Okay, so that's our next priority, is our powers, usually an exponent, but also a radical. Then we do multiplication. And then last is addition. Of course, we have to remind the students and put division up here. They're essentially the same operation, so they have the same priority. So if we do have multiplication and division in the same problem, they are done in the order they're written. They are equals. Same thing here. We have to remind the students that subtraction is paired with addition, obviously. And subtraction and addition the lines between them become blurred because we can change the sign and add. The lines between division and multiplication become blurred because we multiply by the what? Remember? The reciprocal. And here we're going to add the opposite. I just taught a lot of this yesterday in 7th grade math, so I'm a little confused about what I said in here and what I said in there, because they're learning exactly the same thing, not quite in the same format. But so order of operations is something that I'm sure you've practiced and used all through high school, and that is something that is a part of your homework. The homework for this section is on negative numbers and order of operations in chapter 10. All right, so we're going to get to that in just a little bit. All right, so there's our contrast, arithmetic versus algebra. And when we are teaching it, we have to do a couple of things. We have to do this transition. We have to enforce and reteach the order of operations. And we have to make our contrast, and we begin with what? What do we begin with when we're starting a new section, new topic? Yes? Terminology, yes. All right, so now we have to transition from the idea of whole numbers to what? Integers. What are integers? Integers include now the negative numbers. An integer is defined as all the whole numbers and their opposites. That is a term as well. And we'll come back to that. All of our whole numbers and their opposites are integers. So integer is not exactly the same as whole number. It's now replacing whole number. Fractions are now called what? Rational numbers. Key part of that is the word ratio. For example, we have fractions, we have whole numbers, fractions, and mixed numbers. And we have whole numbers, fractions, mixed numbers, and decimals. And we kind of can go back and forth between here, mixed decimals, but decimals are not really a part of algebra. We'll see them from time to time in application problems because we do use algebra to solve problems involving dollars and cents and so forth, and even measurements in geometry. And we do use decimals in algebra. I'm not saying that we don't, but we don't use them nearly. We don't interchange them. We have to learn how to deal with what is called reduced rational form. I have to cross this one out. Mixed numbers are also not a part of algebra unless it's a story problem, an application problem. What do we do when we have a fraction involved in an equation? What if I have this? What if I have 8x equals 4? I've worked my equation down, Guess what many students answer? Off the top of their head. Because they have fraction phobia. And that fraction phobia becomes a misunderstanding of what rational numbers are. Rational numbers are numbers that are in the form of a ratio. Okay? Yes, it's a form of a fraction. And there's a formal definition of rational number. But what we do here is when we inverse the 8, we end up with a fraction. We don't do 0.5. We don't start mixing in the decimals. If I have another one, I might have something like this. 2x equals 9. What is the answer? The answer is 9/2. It is put in reduced rational form. It is a ratio. We don't go to mixed numbers. You say, why not? You're being picky. Well, that's not how algebra is done. So where do I start with that? I start with that in pre-algebra, and as a matter of fact, both the 7th and 8th grade book introduces and uses reduced rational form. And students hate it because they're so programmed to convert that to 4.5. In algebra, it's not 4.5. We're not dealing so much with fractions. We're calling them rational numbers. We put them in reduced rational form. Or maybe I have something like this. 6x equals 15. I'm going to express my answer. How? What is this? 5/2. That's reduced rational form. The answer to that equation would not be 2.5. It would be 5/2. All right, and if you're going to teach pre-algebra, and you might think you're looking at your curriculum, or I'm looking at the Bob Jones book, the first time I went through it, I say, why are they doing reduced rational form? Here we are in chapter 3. We're nowhere near the pre-algebra section, which is chapter 11. Okay, why are we introducing rational form and number line? Because that's how algebra is done. And so, it's a good, if it's that transition, you can't throw it at them all at once. It is a good idea to sprinkle it throughout the coming months before you get to pre-algebra. So, whole numbers now include the negative numbers, and we call them integers. Fractions are still the same. We're going to approach them differently. We're going to call them rational numbers. We're going to center in on the word ratio, and we're going to write our answer as a ratio. If you call it that, that also helps them not to go to 2.5. I start marking them wrong, and I mark them wrong in Algebra 1. I do not accept this, and I do not accept this. Okay? That's not how algebra is done or expressed. Okay? So let's learn the little details from the very beginning. I still, every once in a while, on the homework I graded last night, a couple of the guys went to decimals. I marked it half wrong, even though it was equivalent. It's like, okay, guys, this is April. We're in the end of Algebra 1, and algebra uses rational numbers. All right, let's keep going. Terminology and how we say things and how things are used changes. Of course, this one is another one. This one is going to be phased out, but we're not going to stop using it, and it's not that it's incorrect. Okay, and this is another little key thing here to help students master negative numbers. And. Because we're going to do less and less minus, and instead of saying 3 minus 8, I'm going to see that and I'm going to think 3 and negative 8. What is 3 and negative 8? They don't have like signs. So I cannot add them. It will not be 11, will it? It will not be negative 11 either. What is 3 minus 8? That's not correct. It's 3 and negative 8. What is 3 and negative 8? Negative 5. What am I doing? I'm forcing them to add the opposite from the very beginning and even in how I expressed the problem. When they were in 4th grade and they saw 3 minus 8 in a subtraction problem, might have been Mrs. Haiti, might have been somebody else, they'd say 3 minus 8 and the students would say, can't do it. We have to borrow. Well, that no longer applies, does it? So we're not even going to say 3 minus 8. We're going to transition them into negative numbers by changing minus into and. If you had me in Algebra 1, what did I tell you about adding negative numbers? I said this. Assume what? Do you remember? We didn't go through the number line, because that's a bit confusing. I told you to assume addition. And I told you to start using the word and. Okay, so I'm going to less and less use minus, especially when I do that problem. That's going to be read 3 and negative 8. Or 4 and negative 8 and negative 7. So even though it looks like subtraction, the subtraction becomes invalid because 8's bigger than 4. And certainly we're going to get too big here. So what do? We assume addition. 4 and negative 8 and negative 7. So what do? We just do it as all addition. And this kind of helps us to change the sign mentally. What is this? The first thing we do is we go with our like signs, don't we? What is negative 8 and negative 7? Negative 15. It's much easier to think of it as addition, not minus. Okay? Subtraction is going to be phased out. All right, so that's 4 and negative 8 and negative 7. It becomes 4 and negative 15. What is 4 and negative 15? Negative 11. And this is going to help us master those negative numbers. We don't want them having to stop and think and get confused and go back in their mind to this rote step. We want them to understand that subtraction is no longer its own operation. We're going to change the sign and add. We are going to go with addition. Okay? And then minus also, not only do we assume addition as our basic operation, minus has to be shown like this. The only time we really subtract in algebra is when it's specifically indicated as a separate operational sign, and even then, it becomes opposite of. Okay? Less and less, we're going to phase out minus in our terminology, and we're going to replace it with addition. We're going to use the word and. All right? But a little bit of a we are phasing it out, but we're not going to completely eliminate it. I tell the 7th graders, or I will tell them the next few days, I'm going to tell them that in some cases, we can go back to what? Good old subtraction. If the minuend is larger than the subtrahend, just subtract. We don't have to make it complicated. Okay, so what's 4 or 8 minus 4? It's still 4, even if we're in 7th grade and it's algebra. Okay? So the only time I really enforce the negative numbers would be if I had this. I wouldn't say 4 minus 12. I'm going to say and I'm going to use addition. This is 4 and negative 12. What is 4 and negative 12? Negative 8. Then their negative numbers become a part of their knowledge. And they're not always thinking, okay, the signs are the same. Add their value, take their sign. Or the signs are different. Subtract the smaller from the larger, take the sign of the larger. What is that? Rote steps. Instead of understanding what has happened to subtraction. Less and less, I'm going to use minus. Okay? Because this becomes a point of tripping over things. For example, fortunately, don't do it to the 7th graders. Do it to the 8th graders and the 9th graders. We start playing games with their mind. For example, can anybody read that? That's the opposite of the absolute value of negative 6. And what is it equivalent to? Negative 6. See what I mean? Explain that to a 7th grader. Okay, so more and more we want to start transitioning them from arithmetic operations, arithmetic terminology, arithmetic format as we go through 7th, 8th grade, especially in the pre-algebra sections, because they're going to have to take, in our academy, they're going to take Algebra 1 and then Algebra 2. Okay, so we can help them from the very beginning. What's next in our 7 steps of progression? What? Facts. What can we do? What can I do in the next few days to help my 7th graders? Pull them out of the bottom drawer in my desk in 428. What am I going to pull out of my drawer in my desk in the 7th and 8th grade classroom? I had to make them myself. Couldn't buy them. What can I do? Yes?
Adding and subtracting.
Flashcards. I have flashcards. And, don't forget when you make flashcards, always notch them so you know which direction they're facing. And I have this. And I can tell them to add or subtract. Not add or subtract. I can tell them to add or multiply. What is this? Add. Negative 5. Multiply.
6.
Positive 6. Okay? So, because I'm not really drilling any negative number facts, but I'm getting the mental math going. And how am I going to do it? I'm going to do it through addition, not subtraction. I might have 12 here on my flashcard. 12 and negative 4, what can I use? Good old subtraction. That's still 8. Because things, in mathematics, things are not changed. They're changed, I don't mean that, but that doesn't mean that everything in arithmetic is not true. 12 minus 4 is still 8, isn't it? So I can go back to good old subtraction. Okay? So I have 4 days this week to get the negative numbers down. in 7th grade. We'll see what happens. They were introduced in 6th grade, so we'll see. But I'm going to spend a lot of time in 7th grade getting those negative numbers down so that Mrs. Dameron, when she teaches pre-algebra, can just start doing algebra instead of tripping over the negative numbers. All right, so terminology, facts. What's next? Concept. So all of these things I've just talked about and different terminologies that we are going to be introducing are all going to be based on the number line. So when I'm transitioning from arithmetic to algebra, I have to pay a lot of attention to concept. I want to avoid procedure. When I'm teaching the negative numbers, I want to avoid the procedure and try to get them with the concept. Okay? Otherwise, I'm going to have sign errors constantly. All right, so the concept in the beginning is all going to be the number line. The number line is the basis for greater than or less than. It's the basis for less than and greater than. The number line is the basis for absolute value. The number line is the basis for negative numbers. The number line is how I introduce integers. I kind of avoid the number line with teaching the negative numbers because it causes more confusion than it's worth, and pick it up later. But how do I, it also is the basis for teaching opposites. All of this is a big part of concept. Yes, I can tell them about greater than and less than. These are the symbols of order. I can tell them about absolute value. We can talk about negative numbers and integers and opposites, but we have to solidify it in the concept of the number line. First of all, the first thing I would do is introduce the negative numbers. Okay? What is a negative number? It's any number to the left of 0 on the number line. And as I go left, I am pointing to the left. As I go left, which is why this is less than. It points to the left because any number to the left of another is less than. So, -2 versus -4. -2 is greater than -4 because when I look at -4, -2 is to the right. So then a positive number is any number to the right. And numbers become greater as they go to the right. And this is a very important concept to solidify with the number line. Because then in Algebra 1, I have some students that were solving an inequality. They work it all down. They learn how to reverse the symbol. We get it down to x is greater than or equal to -3. They go to -3. They color it in because it's or equal to, and then they ask me, which way do I shade? All the time, 9th graders are asking me, which way do I shade? And I'm like, what do you mean, which way do I shade? Which way is the arrow pointing? And they're going to start shading this way. Look at the conflict here between this direction and that direction. And then it dawns on them, that's a pretty dumb question. Because you shade the way the arrow points. There's nothing inconsistent. There's nothing that you have to remember. If you understand the concept, you don't have to remember which way, they even say, which way does greater than go? It's like, what do you mean, which way does greater than go? Which way does it go? It tells you, greater than is to the right, never to the left. So when they make those mistakes, they don't know which way to shade. What does that tell you? They don't understand the concept of order. They don't understand y greater than points to the right, y less than points to the left. So everything's going to be solidified on the number line. Okay? What is absolute value? Absolute value is the distance to 0. Guess what? On the number line. So negative numbers are defined with respect to the number line. Absolute value is defined with respect to the number line. All right. Absolute value. What is the absolute value of 5? It's defined as the distance to 0 on the number line, regardless of direction. Okay. So it doesn't matter if I'm going left or right. It's 5 slots from 0, so its absolute value is 5. Or if I have the absolute value of -3, it's 1, 2, 3 units, 3 slots, whatever you want to call them, from 0, its absolute value is 3. Left or right doesn't matter. That is why when we have something like this, or we have something like this, this is called a sign of direction. Why do they call the positive sign a sign of direction? Because it's telling you to the right of 0. Why do they call -5, this negative sign, a sign of direction? Because it's meaning to the left of 0. All of it is defined with respect to the number line. Okay? So you need to see why the absolute value of 5 is 5, why the absolute value of -3 is 3. Don't just tell them to drop the sign. That's procedure. We don't do procedure, we strive for concept. Okay, so when we are beginning our introduction to pre-algebra, we are going to define and solidify, define with respect to the number line, and solidify concept with respect to the number line. Okay, we've already defined integers based on this. This word has to be addressed. Opposite is pretty easy. You can see why it's used. 1 and -1 are called what? 1 and -1 are called opposites. Why? Plain as the blackboard. It's in, I always say it's in white and black. Okay, it's right there in white and black. -1 and 1 are opposites. We have to teach this word because it's not used in arithmetic. Okay? And anytime we are changing the sign, we are changing directions. We are finding opposites. Oops, not same. Change the sign is the same as opposite of. Because we're going on opposite sides of 0. Because positive is a sign of direction. It's to the right of 0. Negative is a sign of direction. It's to the left of 0. All of those are concepts that need to be taught and worked with on several occasions showing the number line. Okay? So when we introduce pre-algebra and we start on our terminology, we have to base it on the number line. Then we can proceed to teaching and working with negative numbers. Okay? And as far as negative numbers are concerned, we're going to begin. All textbooks begin with addition by itself, followed by subtraction. So we've got to deal with addition by itself, and then we will bring subtraction over later, next day, a few days down the road. So we're going to bring subtraction over after we get this guy down. And guess where I'm going to go back to? When you teach addition of positive and negative numbers, you have to go back to the law. What is the law? What is the law? Only add what? Like quantities. How does that apply to negative numbers?
Like terms.
No. You can only actually add like what? Signs. Back to this versus, we're not going to start with that, we're going to start with this. And we have to teach and work towards that. This is what I mean by assuming addition. So when I teach negative numbers, I don't want to teach rules. Okay? I want to teach concept because the rules are going to be mixed up. There are sign rules, but they're based on the law of addition. The sign rules say when the signs are the same, you add their absolute value and keep their sign, right? That's unnecessary if we use the law of addition. We can only add like signs. Oops. Notice the horizontal format, the number written below. I also avoid the equal sign. Why? Number one, it's not an equation. Is this an equation? And number two, guess what happens? The negative sign gets lost in the equal sign. Okay? So we're going to use the law of addition when I am teaching it. So I can only actually add I can only actually add numbers that have like signs. When I get to unlike signs, I can't add them. It violates the law. What do I actually do? I subtract and take the sign of the larger. I have to subtract this. And if I've done my job earlier with my number groups, when I assume addition and I use the operation of addition, I can reorder this. This is 8, this is negative 4. 8 minus 4 is still 4. When the signs are not like, they cannot be actually added. I'm not going to add the 4 to the 8. It's never going to be 12. It's never going to be negative 12, is it? I have to go to subtraction. Okay? And then, so when you're doing your homework, just assume addition unless subtraction is specifically indicated. Okay? So, I get used to adding. I get used to calling this negative 4 and calling this negative 8, not minus. This is not minus 4 and minus 8. Don't say it. Don't let them say it. And then eventually, what do I want to do? I want to assume addition, so I don't need to write that symbol anymore, do I? Is that symbol necessary? Are these parentheses necessary? You've had a couple years of algebra, I'm guessing, in high school. You would never write it that way. You just know that's negative 12. So that's why I'm going to start saying and I'm going to gradually stop writing the addition sign. I'm going to gradually stop writing the parentheses. I need the parentheses at first, and I don't let anybody say minus 4, minus 8. That's not minus 4, minus 8. It's negative 4, and what's the word? And negative 8, which is negative 12. And so we want to put it below. It's taken me all year to get the 7th graders to put it below. Avoid that equal sign. Write the answer below. We don't need the equal sign. We're going to do enough with equations later. All right, so when you're working with negative numbers, you assume addition. When the signs are not alike, we can't add these to 5. We subtract them and take the sign of the larger absolute value. Okay, so we're dealing with absolute values here. Okay. Then We will also use the law of addition when we have to add multiple. This is -3 and 7 and -8 and 4 and -12. I am going to use several properties of addition here. Addition is commutative. That means I can add in a convenient order. Addition is also associative. Oh, why did I learn those? So I can use those. So I am going to group the like signs together, and I'm going to get -23, right? Then I'm going to group the positives, and I teach them to always write the positive one first, because then I might be able to go to good old subtraction. So what's 11 and -23? What is it? -12. Okay? So I use the properties of addition. We also have another property called additive inverse. Sometimes I can use that and my problem becomes easy. What if I have a string of add-ins like this? What do you see there? What do you see there? I see a +5 and a -5, do you? I'm not going to go through the whole commotion of adding those. What's the answer? 1. And what we can do is we can do these things with our long string of numbers, and we can teach the students the properties, and we can actually have fun with it. We can look for additive inverse. Okay, we wouldn't start with that one. We would start with this one. Okay, see how fun negative numbers can be? Then to transition to subtraction, we don't subtract unless it is specifically indicated. I must be told to subtract, which means I must be told to change the sign. How am I told to change the sign in algebra? I am told by this combination of symbols. So unless I am told to change the sign, I don't. I always add. Okay? If we go through the sign rules, we have 2 sign rules for addition. Like signs, unlike signs. Right? Like signs, we add their value, take their sign. I can still hear the 7th graders chanting it from more than a decade ago. Unlike signs, subtract the smaller from the larger, take the sign of the larger. That's kind of bypassing the upper levels of their brains, aren't we? What was the rule for subtraction? Change the sign and add. So I'm always going to addition anyways. So on your homework, on the quiz coming up, I'm going to give you strings of numbers. What do? You add them. You don't subtract unless you are specifically told by this combination of symbols to change the sign and add. So what do? Let's say I have this. This is the only time subtraction, which is now sign changing, becomes involved. And when I'm doing a sign change, I have to always change 2 signs. So what does this become? -3 and 8 and 7 and 6. What do? I collect my positives and I write them first. Then I collect my negatives, and then I got a simple, good old, easy arithmetic subtraction. Okay? Now, if the positive one is too small, I do have to use my addition rules. okay? Multiplication and division are easy. The only problem with multiplication and division is sometimes it causes us to be confused with addition and subtraction. What do you know about the sign rules with negative numbers with multiplication and division? You probably at least remember that you didn't have a problem with them. Why do they not have a problem with them? Well, multiplication is not governed by the law of likes, is it? So, we'll go back to times. Actually, single multiplication is best represented by raised dots. Okay? So what are we going to do? Three times 5 is 3 times 5 is 3 times 5, no matter what the signs are. Right? I still have 15, but positive times a positive, there's no sign involved there at all. Here's where we get some problem. This is kind of an obvious one. A negative times a positive, it stays negative, and doesn't matter which factor is negative. Two negatives cancel in multiplication. They do not cancel. Let me put my dot here. They do not cancel in addition. But the nice thing about multiplication and division we don't have to learn separate rules for division. And then we had, I guess I'll go ahead and do this. Negative 15 divided by, and then negative 15 divided by positive 15 at any rate. Two negatives give me a positive 5. No negatives give me the positive 5. One negative gives me a negative 5. One negative gives me a negative 5. The rule is consistent. I'm still going to get the same quotient or the same product, but we can summarize this as multiplication and the division itself doesn't change, but the sign of the answer is determined by how many factors are negative. If we have an even number of negative signs, they cancel in multiplication and division. Odd number, they do not. All right, just for a second here, let's talk about your homework is doing the integers and the absolute values in chapter 10 of your textbook. But then the hard part is applying the order of operations on 10.4. 10.4 the section is called Operation on Rational Numbers. And the whole point of that is to realize that not only do we have to apply the order, not only do we have to apply the signs, we also have to work with what kind of numbers?